Hey everybody, welcome to Supplementary Video 1.7. In this video, we're going to be talking about different types of medical imaging. Again, just a reminder, this is only our second video, so if you're having questions or having any problems, please make sure you're communicating with me and make sure you're keeping up with the videos, not only for the high school portion of the class, but also for the dual credit portion of this class. Okay. So we're going to start with X-rays. X-rays were first discovered in 1895. They were actually discovered by accident, but they quickly realized the possibilities with X-rays, and they were used in the medical field in a wide variety of uses by 1900. So it only took about 5 years from their discovery to basically any medical doctor was using them. Today's X-rays will use a machine that fires X-rays towards a patient that has a special metal plate located behind them. Soft tissues are going to partially block those X-rays from reaching the special metal plate, and hard tissues are going to completely block those rays, which means that the areas that appear light on that plate when you take a look at it, basically the picture you're looking at, are going to tell you basically the density of those tissues. And so X-rays today are actually very, very useful for looking at things like teeth and bones. Issues with X-rays, though, they can cause cellular damage. They are high energy rays, and they can cause damage to your DNA, which can potentially lead to cancer. So they were used a lot back in the early 1900s. Today we're a lot more familiar with the dangers of X-rays, and we want to try to limit exposure to X-rays as much as possible, which is going to be important moving forward. And here is an image of an X-ray. I'm sure all of you are familiar with an X-ray. Next up, we have computed tomography, and this is going to be abbreviated CT. Computed tomography is going to use a computer, and it's going to take several X-ray images, and it's going to piece them together to form basically a more complete image. It's going to use a computerized axial tomography scanner, or a CAT scan, in order to use this. So you'll see a lot of times CT or CAT scan used interchangeably because it is that CAT scanner that's going to be taking the pictures. CT is very useful for viewing soft tissues because you're going to get a closer to think like a 3D-ish image, but it is very, very dangerous because you're exposing that person to a lot of X-rays because you're taking all those X-rays and then piecing them together. So these are some examples. This is what a computerized axial tomography scanner would look like. So you're going to slide in. It's going to do those scans, and then you can get all these images. Basically, what it allows you to do is look at different depths. So the image you're going to be looking at is going to be a two-dimensional image, but you can alter how deep or how shallow that two-dimensional image is. So if you only want to look at a very, very shallow or superficial layer of the brain, you can do that. Or if you want to look at it a little bit deeper, you can also do that as well, just by changing how deep you are and what image basically you're looking at. So it's a two-dimensional image pieced together in sort of a three-dimensional way, but it is very dangerous because of all those X-rays. Magnetic resonance imaging, or MRIs, takes advantage of a lot of physics here. So when matter, which is basically any physical thing for our purposes, is exposed to a magnetic field and radio waves, that matter is going to emit its own radio signal. What we found out is that a tumor or a cancerous growth is going to emit a different radio signal than a healthy tissue will. So that can be useful if we're trying to figure out if something is a tumor or not. MRIs are very, very expensive to conduct, but they have the benefit that they do not expose the patient to any radiation. It's just a magnetic field, radio waves, so they're not getting any radiation. You just got to be mindful of that magnetic field, because if somebody has a metallic implant, these are very, very strong magnets, and it can cause it to fly across the room, rip it out of their chest, whatever it might be. So you do have to be mindful of that. I don't want anybody getting their belly button piercings pulled out or anything. A version of MRIs known as functional MRIs, or fMRIs, are really cool because they can detect the concentration of blood flow in a system. And what we can do with that, especially today's research, is we can look at blood flow within the brain. So if we're looking at what areas of the brain are responsible for controlling different things, we can see, okay, if you are doing a math equation, what area of your brain is getting lots and lots of blood flow? And maybe there's some links to research there. Maybe if you are singing, what areas of the brain are getting lots and lots of blood flow? And with functional MRIs, we are actually able to picture that. Another one, positron emission tomography, or PET. It's going to use radiopharmaceuticals to look at the physiologic activity of the body in real time. Radiopharmaceuticals are basically a chemical, a substance that's going to be radioactive for a very, very short period of time. And so because it's radioactive for such a short period of time, we deem it to be safe for use. So what's cool about PET is that X-ray, CT, and MRI are only going to take a single picture at a single time. With CT, it's going to take those single pictures over at multiple times and at multiple depths and things like that. But PET can actually follow that radioactive material for the entire time that it is in the body and that it is radioactive. So this can be useful for something where we're trying to figure out if there's any sort of leakage in a blood vessel or leakage in the digestive system. We can actually have you swallow that radiopharmaceutical, and we can actually view that radiopharmaceutical as it travels through your system. And then lastly, we have ultrasonography. This is going to use high frequency sound waves. They're going to penetrate the body and create an echo, and then the system is going to take the echo and convert it into an image. Ultrasonography is very, very safe. You're just using sound waves. And so we see ultrasonography used a lot during things like pregnancy. The only, or I should say, one of the downsides with ultrasounds here is that you're using sound waves and it's taking an echo and turning it into a picture, which is going to cause a lot of the quality of your image to decrease. And so it's very difficult to get a high quality image using an ultrasound. So you need a very skilled operator to get something that is useful to look at. And another thing with ultrasounds is that sound waves, they travel best through soft tissue, and so they struggle and usually cannot penetrate anything that is bone or anything that is gas, because those sound waves just can't travel through them. Okay, so that is video 1.7 on medical imaging. Again, if you have questions, please let me know, and the videos are always going to be named based on the section in the textbook that they're named after. So if you still have questions, want to learn more on medical imaging, you can just go to the textbook, and this is on, you can find this under section 1.7.